Hello and welcome to the Half-Life revision video from scienceworksheets.co.uk. Please subscribe to support the channel and watch all of the video to help you to learn all of the content for your exams. We're going to have a look at what half-life is, how to draw half-life on a graph, and deal with half-life calculations. Half-life is the average time it takes a number of radioactive nuclei in the sample to decay. Now, each radioactive isotope has its own half-life. That half-life might be very short, for a fraction of a second, or it could be very long, thousands of years. We can use the Geiger counter to measure the count rate over time of a radioactive sample, and we can record that in a data value table. So as time increases, the radioactive count rate will decrease from the sample. We can now plot our data on a graph using the activity or counts per second on the y-axis against time in seconds on the x-axis. And if we look at the starting point where you've got 0 seconds and the count rate is just about 240 from the data table, we can highlight that point. Now, if we want to calculate the half-life, we need to halve that value. So half of 240 is 120. Then we will draw a green line from the 120 across to the graph line and then down to the time axis. And that will be approximately 159 seconds for the first half-life, because half-life is when the activity of the sample halves. Now, make sure you draw the half-life on the graph, because often there is a mark for it. Then we will repeat this. So half of 120 is approximately 60. So we go to 60 on the y-axis and draw another green line horizontally to the graph and then down. And that will be a further 159 seconds from the last half-life. You can see that we've highlighted these on the graph. To prove constant half-life, you will need to draw at least 2 half-lives in the exam. Polonium-210 has a half-life of 140 days. If an original sample of polonium-210 has an activity of 500 becquerels, what will its activity be after 280 days? So that means that every 140 days the activity will halve. So if we start the activity at 500 becquerels, after one half-life, which is 140 days, the activity will be 250 becquerels. After 2 half-lives, which will be a total of 280 days, the activity will be 125 becquerels, which is the final answer, 125 becquerels. A scientist discovered a new radioactive isotope, which he called alphium. The count rate was 600 becquerels and decreased to 150 becquerels over a period of 9 hours. What is the half-life of alphium? Now, the half-life is the time taken for the activity to halve. So if the activity starts at 600 becquerels, after one half-life it will be 300 becquerels. And then after a second half-life, the activity will be 150 becquerels. Now that took 9 hours in total. And there were 2 half-lives, so it will be 9 hours divided by 2 is 4.5 hours per half-life. Thank you for reaching the end and watching the video. Please subscribe to support the channel to help us to produce more videos. Revision worksheets with fully worked solutions are available at scienceworksheets.co.uk.